Hey guys, so today we're going to talk about what it means to solve an inequality. So just as a refresher, when we are presented with a situation that has a range of solutions instead of just one solution, this is known as an inequality because the solution isn't not equal to any one number. So for example, in this situation down here, it says the McDonald family spends no more than $150 for groceries each week. In this situation, the money they spend is not equal to 150, not necessarily, okay? This isn't the only solution. The money spent is not going to be just equal to 150. It says they spend no more than 150. So that means they could spend anything up to 150, okay? So the solution is not just represented by 150, it's represented by all the numbers less than 150. That's an inequality. It's a situation where there's not just one possible solution, there are many. There is a range. Okay? Let me get rid of that. So, we can solve for a range of solutions the same way we quote-unquote solve for a missing value in an equation. When we solve equations, what we're actually doing is rearranging the equation to find the number that makes that sentence true. You can see here that it says inequalities can be rearranged to solve for unknown values, just like an equation, but with a few exceptions. All right, let's take a few seconds let's take like a minute to go look at solving equations for a second, right? So if I have x plus 3 equals 4, this is an equation. We are looking for the one number that if we replace x with it makes a true statement. We are solving for what is the one number that x could be, all right? We did that by using inverse operations. We isolated our variable using inverse operations. So something plus 3 equals 4. There's only one number that could be. So we are going to isolate x to figure out what that one number could be. We isolate it using our inverse operations. So the opposite of adding 3 is subtracting 3. That is 0, and so what we're left with is x on this side. We have isolated the variable. Now the important thing here is to remember that we have to keep the equation balanced. So whatever I do to this side, I have to do to this side. So I took away 3 from that side, so I take away 3 from this side. So I'm left with x on this side and 1 on this side. What we are saying with this solution is we are saying that the one value that'll make this true is literally the number 1. We can check our work by plugging in what we're saying x is into our original equation. So we're saying x is 1. Let's plug it in. Okay, is 1 plus 3, 4? Well, yes, it is. 4 is 4. Okay, so let's look at how solving inequality is similar, but also a little different. Okay, so solving one-step inequalities. The variable must be alone or isolated on one side of the inequality. That part's still the same. Our goal is still to rearrange our inequality so that we can clearly see what range of solutions our variable represents. Okay, we want to isolate that variable using inverse or opposite operations. Once again, same thing. Here, it says whatever you do to one side, you must do to the other side. Once again, we got to keep it balanced. If I just do something to one side, I haven't solved the inequality or solved the equation. I've just created a new equation, right? So we got to keep it balanced. This is the new part, and we'll talk about this in a few minutes. When you multiply or divide by a negative number, the inequality sign flips. We will come back to that. So let's look at a few examples. Keep in mind down here, I have 4 examples completely worked out with written out explanations and everything. So I'm going to do the same thing to 2 new examples on the next page. but I just want you to be aware that these are examples you can read over, all right? Please read over them. So let's look at the inequality f plus 16 is greater than 22. What this is saying is literally what values, right? Some values plus 16 will give us a number greater than 22. And so that's what we're solving for. We aren't solving for just one number here. We're solving for a range of numbers, because there's not just one number that if we add it to 16, we get something greater than 22. There are many numbers. So we are going to rearrange this inequality so that we can clearly see what all of those numbers are. So on this side, we have f plus 16. So I'm going to do the opposite of adding 16. The opposite of adding 16 is to take away 16. Those will cancel and leave us with just f on this side. Okay? We have to keep it balanced though, so we need to do the same thing on the other side. 22 minus 16 is 6. Right? Our inequality symbol in this case is going to not change. Right? So this is our solved inequality. F is greater than 6. What that means is if f represents a number greater than 6, then our original inequality, this inequality right here, okay, then f plus 16 will be greater than 22, all right? Now, we can say that and we can claim we did it correct, but the only way we're going to know for sure is if we put it on the number line and then we check it. So let's do that. Let's put it on the number line. So we want to represent all of the numbers that are greater than 6. Okay, so we are comparing our variable to 6. So that's our boundary point. That's where we're going to start. Put a nice dot here at 6. Now, I am not going to color in this dot. I am not going to color in this dot because 6 is not one of our solutions. If I replace f with 6, I have the statement 6 is greater than 6. That is not true. So we are going to use an open dot because 6 is not included in our solution set. And then the only thing we have left to do is to draw an arrow to show all of our possible solutions. F is all of the numbers greater than 6. So I'm going to draw an arrow better than that one to show all of the numbers greater than 6. Once again, we need to check our work. We need to check our work because I understand that this is a really abstract concept. And unless we check our work, we're not really going to be sure if we did it correct. So we check our work by testing our solution set. We're going to pick a number that's greater than 6. So let's pick, I don't know, let's pick 9, okay? So if I use 9 for f, let's put that into our original inequality and see if that's true. Is 9 plus 16 greater than 22? Yes, we get 25, and 25 is greater than 22. Great, we have solved our first inequality. Let's look at an example, because this example is very similar to how we solve equations except for graphing it. We're going to look at an example that's a little different, right? If I have f divided by -3 is less than or equal to 4, what the heck does that mean? we want to know what values, right? Because f represents unknown values. So what values divided by -3 give us a number less than or equal to 4. Okay, I'll show you why this one's different in a second. It's different, first of all, because we're dealing with multiplication or division. But here is the one stipulation. Remember, we said if we multiply or divide by a negative number, the inequality sign is reversed. Okay, so if you look at this inequality, our goal here is still the same. We want to know what range of solutions will work. We want f by itself. So we need to use our inverse operations. Our inverse operation here is the opposite of dividing by -3. The opposite of dividing by -3 is to multiply by -3. Okay. -3 divided by -3 is just f, right? We've isolated our variable. We need to balance, so we got to do it to this side too. 4 times -3 is -12. So we have f on this side and -12 on this side. Now, we have just multiplied or divided by a negative number. Negatives are the opposites of positives. So since we multiply or divided by a negative number, we need to use the opposite of our original inequality symbol. We need to use a greater than or equal to symbol. So because we multiplied or divided by a negative number, we had to use the opposite inequality symbol when rewriting the inequality. So this solution says that if f represents a number greater than or equal to -12, then our original inequality, our f divided by -3, will be, or it should be, less than or equal to 4, right? Because that was our original inequality. Once again, this is kind of confusing. I'm aware of that. It's kind of complex. So let's put our solution on the number line and then check it. That's where things really start to click. We put our solution, we put this f is greater than or equal to -12 on the number line and test to see if a number in that solution set works. So let's put it on the number line. We have, I'm going to add -12 onto here. So we are saying our solution set is f is any number that is greater than or equal to -12. So let's put that on here. So we are comparing our variable to -12. So that's our boundary point. Here is what's different than the one before. This has an or equal to line. Okay, so that means we're going to fill in our dot. That means 12 is included in our variable set. If we put 12 for f, 12 is greater than or equal to -12. So we're going to fill in our dot. 12 is included. All right. And then we just need to use an arrow to show that our solution is not just -12, but it is all the numbers greater than -12. That is our solution set. And this is me drawing a better arrow because I am a perfectionist. Okay, so this is what we are saying our solution is. We are saying our solution is all of the numbers greater than or equal to -12. So let's check by get a different color. Let's check by picking one of those numbers. I'm going to pick 6. So we're going to check our solution set by saying, well, what if f is 6? Let's plug that in to our original inequality. If we put in 6 for f, is 6 divided by -3 less than or equal to 4? Well, 6 divided by -3 is -2. -2 is less than or equal to 4, and we are good to go. So remember, guys, when we're solving inequalities, we are finding the range of solutions that make our inequality 2. I didn't have to pick 6 to check my work. I could have picked 9, -5, 4, because there are many values that we could use for f to make our inequality true. There are many values for f here that I can use that when I add to 16, I get something greater than 22. So we're solving for a range of numbers here. The only thing that makes this different than equations is the type of answer we're getting. We're not getting just one number, we're getting a range of numbers. So keep that in mind. The rules are basically the same, except you have to remember if we are multiplying or dividing by a negative number, we have to flip the switch, as my old algebra teacher used to say. She literally used to turn on and off the lights whenever we would multiply or divide by negative numbers. So read over these notes, please. Okay, read over these examples and work on your weekly assignment. Love y'all.